The Super Duper Looper. The total energy in the world is always the same. When you move up and down on the ride, energy should always be conserved. But some energy is lost to non-usable forms like friction. On this ride, you need to consider how much energy is actually lost. Is all the potential energy converted to kinetic energy? You will consider how the total energy compares. Start by making a prediction. How does the energy at the bottom of the first hill compare to the energy at the top? Before you go to the park, calculate the potential energy. The mass and height are given in the engineering specifications. For this lab, you will need the stopwatch and the vertical accelerometer. At least one person in your group will have to ride the Super Duper Looper. The first measurement you have to take with a stopwatch is the time for the train to pass the top of the first hill. Stand off to the side of the coaster and wait for the train to get to the top of the first hill. Pick a point at the highest point on this hill. Start timing as soon as the front of the train reaches this point, and stop timing as soon as the back of the train reaches that point. Repeat this at least 5 times and take the average. Record this on your lab. Repeat this for the speed at the bottom of the first hill. Pick a point at the very bottom of the hill before it goes into the loop. Start timing when the front of the train reaches this point, and stop timing as soon as the back of the train reaches that point. Again, repeat this at least 5 times and take the average. Now that you have all the times, wait in line for the ride. While you're waiting, do the calculations. The velocity is equal to the length of the train divided by the time that you measured in the last step. Kinetic energy is 1/2 times mass times velocity squared, and the total energy is the sum of the potential and kinetic energies at that point. You will need the vertical accelerometer when you ride the Super Duper Looper. Make a prediction. How does the acceleration at the bottom of the loop compare to the top? Is it the same or is it different? You have to read the accelerometer at the bottom of the loop and at the top. It is very difficult to look at the accelerometer and tell where you are in the loop. It is easier if you hold the accelerometer and focus on it. Have your partner yell "now" when you are at the bottom of the loop and again when you are at the very top. These readings are very close together, but you should be able to get both readings by riding the ride once. Finish answering the questions and make a graph of potential energy versus time. Remember, the potential energy will be based on height. Start your graph at the top of the first hill and draw the graph of the entire motion as it goes through the loop until the very end of the loop. Good luck!